Okay, here's your model, and man, there's about 10 ways we could do this. I don't know that I'll pick 10 ways, but number one, the reason that this looks the way it does is you've got too many profiles along the way here. There's too many cross sections that aren't needed. So based on that, that's why it's I call this the undulating surface. And here's the problem with Rhino. It's not a problem, it's just the way it works. You've got this profile and it's coming along here, and then this profile is wider, yet the surface always has to be perpendicular to the profile. So right here, this surface is perpendicular to the profile right here. So that's straight. So here's what it does. It's like, okay, I'm perpendicular, and then I come out and I bow out. Oh, I gotta be perpendicular, so it goes in. And then it says, oh, there's a new profile, so now I gotta head back out, and so on. So that's why it's rippled here. The other thing that you don't really want to do is, if you're going to use an outside rail to influence the shape of the ring, you don't want your profiles to ever stick out past the rail, because then you start to get this choppy where it's coming along and it's like, oh, I'm following the rail, oh, I see a profile, I need to go up and hit it, and then I need to come back towards the rail, and that's what happens. So the other thing in looking at this ring that I'm not quite sure how you want it is, you know, it looks like you want this thing to come along here and go out and then head back into a smaller profile, and that's this little bit here. Now I'm not sure if you want it that way. If you want it to be one continuous, then that's fine. But anyway, having said all that, I also understand from the email right here that you're trying to put a 2mm bevel on this model at 20 degrees that would follow the side of the ring. I guess I would wonder 20 degrees if that's 20 degrees this way or 20 degrees this way. I'll show you how to do either one. So here we go. Okay, so first let's say this. Let's work on getting a good smooth surface. So here's the angle, or basically the angle that you want this to come up at. So if we go curve and we draw this angle from here to here and then bend this out. So I would match your surface like so, pretty much like that. Okay, then in this viewport you've got you know, I guess I wonder if you want it to follow the red line or the profiles. I guess the profiles if you put them up there. So in order to do this, what I would do is I would take this curve and I would offset it, and I would go T for through point, unless there's a value you know for sure, you know, 2 millimeters or whatever, then you'd type that in. So there's the distance there, and then I would come up to arc direction, and let's turn yours off, and we'll turn off these for now. And what I want to do then is come over and go to quad, and I'm going to click here. I'm a little bit smaller, but it should be alright. Now let's turn these on. Yeah, okay, end of this, so to there. And then if I hold down shift right here for ortho, by starting my curve here and coming up this way, when I hold down shift, you'll notice that it's not going out too far, and it's not coming in too far. It's perfectly tangent to this circle. Okay? And for instance, here's here's what's going on here. This one's coming out past the tangent point, and so we get this kind of little valley in here. It's pretty subtle, but it's still there. So using ortho will help you get this circle completely tangent into this one. Alright, so now we'll go split with a point, and we'll go right down here and then over here on the tangent point, and we'll throw away that part of it. So really what we're left with is this and this, and we'll hit join. Okay. Oh, except for I snapped up here. Now this, I'm actually glad this happened. So looking at this, we have this curve coming around this way, and I inadvertently snapped to the end of something that I didn't want to. So I'm going to go in this viewport, go to Transform, Project to C-Plane, and delete the input, which is the bad one. Yes, there. Now if you look, it flattened that curve. So here's what we have. We have a curve in this view, and we have a curve in this view, and we want it to we want a curve that mimics this curve and this curve, otherwise known as a curve from two views, which is right here. Curve from two views. Select the first curve, second curve, and there we go. So now we get a curve that not only mimics that one, but also this one. A curve from two views. Alright, so now let's go ahead and mirror that from F4 to the other side, like so. Now, well, before we mirror that, let's take a look also at what we got. So this is the top curve. And what's not happening is it's not coming out to meet this edge here. So really what we could do is, in the looking down, we could turn on the control points, and we literally could just move this out like so, so that that matches this, like so. And I would move this one a little bit more. There we go. Alright, so now the next thing we would do is take this curve and perhaps move it in a little bit more so that it matched the bottom. And here's what I'm looking at, this bottom corner, this bottom corner. Okay, so we'll take that curve and this curve and do curve from two views, like so. Now that one's going to go all the way around. So what we want to do is split it with a point. Oops. Split it with a point here and here, and delete that. So now we have another curve, and again we could pull this one out and that all depends on, let's not pull that out quite that far. Alright, there we go. So now that's heading back in the other way. So we have these two. Let's go ahead and mirror it from F4. So now we've set up essentially a 4-rail sweep that would go around this surface. or around these. So as you can see, oh well, you know, I might have to fix these. If this is supposed to hit this profile, hard to, you know, but I wouldn't need, so we would need to fix that. But I don't need any other profiles because the lines are doing what I want them to. I only need a profile to define the bottom and the top. Now, technically, with these 4 curves, we don't need to sweep anything. Technically, if we want hard edges, we could go to Loft, and Loft from here to here to, not that one, to there to there. Now, right now, it's doing normal. Okay, if we do closed preview, then we get that. And it's going through each point, or each line, as you can see. But what I want is straight sections preview. There you go. There's a surface going through those lines exactly. Now, we'll hit OK for now, and there you can see it's very smooth because it's only following the curves. And it does exactly what we defined. Now, if we do want to sweep, one thing that I contend is that if you want to do a bevel, and the bevel is 20 degrees, at 20 degrees, that would follow the side of the ring, a 2 millimeter long. Alright, so now we're getting into, for me, an art major, some pretty serious, I guess that's trigonometry, maybe algebra. But here's the formula for what you want. Okay, so here's the deal for, here's the formulas for doing the 20 degree 2 millimeter bevel. We have the adjacent, the hypotenuse, and the opposite angles. We know the hypotenuse is 2, and we know that the degree of the angle is 20. And so here's the formulas for tangency, cosine, and sine. And so if we take 2 times the cosine of 20, then we'll start to be able to plug these in. So if we come in and go if we go 20 cosine times 2, we get the adjacent is 1.879 for this distance. And then if we do 20 sine times 2, we get 0.684 for the opposite distance. And if you do that, if you go 1879 and then the 6.84, this distance right here will be 2. So there's a little trip down what all the math is doing. Now, I contend, since I had to go ask one of the programmers this formula and how to do this, so don't for 1 minute think that I was too busy sharpening my crayons instead of doing math as an art major. Here is another way that you could simply do this, and that is you could draw a line to build your profile, and you could start here and type 2 and hit enter. So now we have a line that's 2 millimeters, and then we want the angle to be 20. So if I hold down shift and press the comma button on the keyboard, so shift comma is actually the less than symbol, which is angle, and I type 20 and hit enter, now I am locked to 2 degree or 20 degree increments. So if I draw this and go like that, now I have a 20 degree 2 millimeter line. at which point I'm going to go move and near, and I'm going to move this near this curve which snaps to it, and then I'm going to go move again and turn on intersect, and I'm going to move this till it intersects this line. So now we have lines that represent the angle and the bevel that you want without doing all the other mumbo jumbo. So this was just kind of fun. Now the thing is, over here, if you wanted to test the math, then we could draw a line and go curve from here along here, and the distance on the one was 0.684, 0.684, enter, and I snap to that, and then over here we'll go 1.879, enter, right there. And then if we draw a line from the end of this one to the end of that one, we select this curve and go to measure distance, and oh no, let's just do length. Measure length. We're at 2. We're at 2 millimeters across there. Now, there is a command that we can run the bevel command on. What's that? That's some of your stuff. Oops, let's get rid of that. Okay. There's your original surface. I guess I got rid of my lofted surface. So if we go surface loft here to here to here to here, and do closed loft, okay, we'll put this on this layer. Right over here under surface there is not a bevel command, but what they would call a chamfer in Rhino. So if we click this, first surface to chamfer is this top one. Second surface to chamfer is this bottom one. Oh, except for I never entered any values. Let's hit it again. Distances, 1.879 was the first one. Second chamfer distance was 0.684. And first surface was here, second surface here, and there's that chamfer distance right there. That one doesn't quite match. Oh, because it's not on the curve. So it's still the same. So this measure, this distance right here would be, and it's 2.2. Did I click there? Yeah, I don't know. It's pretty darn close though. Try to polish that and not get rid of it. But so there is the chamfer on that with those numbers, as near as I can tell. This one matches up perfect. It must be that angle that it had trouble with right there. So there's that. Now, as far as closing up the end, now I still contend though that it would be better to perhaps sweep this in such a way that we don't have to rely on figuring out geometry or algebra or trigonometry or whatever that all was. So what we would do is literally make the profiles the way that we want them. So let's go ahead and mirror this over to the other side, and let me get rid of these curves right here, and we would click these and say trim, and by just simply drawing a line the length we wanted at the angle that we wanted. Alright, we can join those up into those curves, and then we can join, or we can trim these. So let's go trim, enter, join. Alright, so now we have a new way to do this. And ideally, these curves would be touching these points on the rail. So let's go ahead, and I'm going to hide these, get them out of our way. So here we go. I'm going to go transform, orient to, and I'm going to take this point and orient it from this corner to this corner, like so. And then I'm going to do the same thing over here on this corner and this corner. Enter, enter. Alright, so now what we have, let's hide these. Now what we have is a new setup where this is all going to go. Oh, I can't do that. We have to mirror this. Let's show this. This one has to be coming from here. That was I didn't think about this being mirrored. So we'll go here to here. Enter, enter, and this one, and this one would be hide. Okay, there we go. Now we're in business. Alright, the next thing I'm going to do is check and see. Okay, yeah. Here's the problem with this. This curve is now changed, and it's no longer associated with, if I hit MSR, F6 MSR, this curve is no longer associated with this rail. Okay? So if we go and select rail curve and pick this curve, oh, that's a problem. Let's hit escape. Not only is that a problem, but check this out. If I go F6 MSR, the origin of this curve is way over here. So let's go edit, edit origin, and let's set this origin to here. Okay, to right in the middle. Enter. Let's check this one. We'll click here, go F6 MSR, edit origin, edit, edit origin, and let's drive it around to here. Enter. Okay, now we'll come back, F6 MSR, and select rail curve, and there's that curve. So now it's exactly back where it was. Everybody's still happy. And the other thing that I want to do is go to edit, and I want to edit the control points so that they're in the corners. Okay? Enter. This one, F6 MSR, select rail curve, it's the finger rail, yep. And then we go edit, and we drive this over to here and over to here, enter, and we should be in business. We may have to trim the finger rail so that it's only going from here to here, but let's see what happens. Okay, so what I've set this up for, by making 4 rails that do exactly what I want, and by making sure that I have good profiles attached to a rail with the edit sweep points in the corners that the rails are, I can come over to Surface and Sweep Multi. Select rail curves, 1, 2, 3, 4. Select profiles, 1, 2. And what happens is it runs the surfaces through all those sweep points, and I don't have any of this business going on because I simply drew what I wanted. I drew this angle, on the profiles and got them where I wanted them. And so I'm in business. It's got a good, nice taper to it based on what I drew. And also I don't have any change in the ripple of the surface this way as well. Now on your original surface, let's put this on a different layer. On your original surface, I noticed that you have a real slow dome going here. And so we would want to close this up. And to do that, I would use blend. Now what we need to do is see where the start-stop points of this open surface are. So if we select this and go to Utilities and say Show Edges, we can see that there's start and stop points at each corner, but there's no seam here and there's no seam here. So what we need to do is I want to split this thing right down the middle. So I'm going to go to Split Edge and select Edge to Split, and I'm going to pick this one and go mid, enter, and then I'm going to select this one and go mid or intersection and hit enter. So now I've split this. If we click this and check it again, now we have a split here and a split here indicated by the dots. Alright, here's what that did for me. If I go back to Surface and go to Blend, I can go here, 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 and here, enter. Oops, I missed a spot. I missed a little spot right here. Right there. Let's do blend again. Blend here, 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 and here. There we go. Enter. Now we go here to here to here to here to here. Enter. There we go. Lock the handles. Drive this down to whatever you want. I mean, maybe even lower than this. Maybe 1.5 or 2.2 maybe. And we hit OK, and that'll drive that around and keep it a nice shallow angle, but still make it so that it'll happen. So so let's see how far we went. Yeah, I'm almost dead on with what your distance was. That was actually a mistake, or well, you know, controlled luck. So there is a chamfer or a bevel based on your angle and length of the edge. All right, there we go.